Today we're going to talk about how to simplify algebraic expressions, and we're going to do so by combining like terms. The first thing we want to do is look at some important vocabulary. Understand this vocabulary will make the process a whole lot easier. First, we need to talk about what a coefficient is. Well, the coefficient is simply a numerical factor. Remember, a factor is something that's being multiplied, so a numerical factor is simply the number in front of your variable. If you don't see a number there, we understand that that number must be a 1. For example, if I'm looking at 4a, 4 is a coefficient. If I look at 10xy, 10 is a coefficient. If I look at negative 6x cubed, negative 6 is a coefficient. But if I look at b, even though there's not a number there, there is one. It's hiding. It's the number 1, so its coefficient is 1. Also, we have to understand how to identify like terms. And like terms are just variables that have the same last name. So they're just like terms that have the same variables, or the variables have the same powers. So for example, 4x and negative 10x are both like terms. They both have numbers and they both have x to the first power. 15xy and 17xy are both like terms because they each have an x and they each have a y, as well as the numbers 15 and 17. You could also look at negative 2x squared y and 7x squared y. Both have numbers, both have x squared, and both have a y. However, if I tried to look at a 7x squared y and say a negative 9xy cubed, they both have numbers, that's true, and they both have x and y, but one has an x squared, one has an x. One has a y, one has a y cubed, so those would not be considered like terms. Here's some examples of some terms, and we're going to decide if they're like or unlike. If I look at this one, we both have numbers, a negative 4 and negative 10, and they each have an x. And the x's, both x's are to the first power, so we would say these are both like terms. If I look at this one, I've got a 17 and a negative 21. We're good there. We have an a here and an a here, a b here and a b there. So these would be considered like terms. If I look at the 5x squared and the 9x, I have a 5 and a 5, which is good. I have an x squared and an x. They both have x's in them, but this one has an x to the second power, and this one's an x to the first power. So we would say these are unlike terms. We'll go ahead and do just one more. Let's say I look at this one. These look very, very similar. They both have numbers and x's and y's. However, the first one has x to the first power, the second one has an x squared. That in itself is enough to say that they are unlike. Now here's some examples that we can look at, some pretty easy ones. Whenever we're getting ready to simplify our expressions, when we combine them, we're going to combine their coefficients together. So for example, I'm going to look for the terms that are alike. In this case, I've got a 3k and a minus k. Both of these are like terms, so I'm going to combine the coefficients in front. This has a 3. Though I don't see one here, there is an understood 1, so that means it's going to be 3 minus 1, so the answer is going to be 2k. And let me see if I can get my toolbar up. I can grab a pencil here. I'll write with red. And so we're going to say the answer is 2. Oops. Okay. Now, let's look at number 2. I've got 5z squared minus 10z plus 8z squared plus c. There's a lot that's going on here. So a lot of times when there's a lot of noise, what we want to do is reorder everything. Let's put our like terms together. Here I've got a 5z squared, and here I've got an 8z squared. So I could write it as 5z squared plus 8z squared. And then I've got a minus 10z. We want to pick the sign up that's right here. So minus 10z. And I've got the plus z on the end. If I reorder it, instead of working right away, it allows me to get things organized, and that way I don't miss anything. So I've picked up my z-squares, I picked up my z's. I can add the coefficients. I have a 5 and an 8, so 5 plus 8 is 13. So it's 13z squared. And I have a minus 10z plus z. So if I have a minus and a plus, I subtract and take the sign of the larger, so I have a minus 9z. So the simplified version would be 13z squared minus 9z. Okay, now let's look at one more example. I've got, let me move this out of the way, minus, I've got m plus n in some parentheses, plus 2 times m minus 3n. Whenever you see the parentheses, remember these are grouping symbols. So I'm probably going to have to distribute. And remember, the minus right here is really an understood 1. So let's go ahead and distribute before we try to combine. So I've got a minus m, because minus 1 times m is a minus m. A minus 1 times a positive n is a minus n. Then I'm going to distribute a positive 2. So that's just going to be 2 times m is 2m. 2 times a minus 3n is a minus 6n. Okay? So when you see your grouping symbols, go ahead and distribute. Then as I look at it, let's see if it'll let me extend the page just a little bit so we can see. Get my pencil back. Go with red. Let's reorder it so like terms are together. And we'll just put the minus m first. And then I've got the 2m, it's a plus 2m. Then I have a minus n and a minus 6n. So I'm just putting the neighbors next to each other. The m's are together and then the n's are together. And then going from left to right, I can combine like terms. I've got a minus m plus 2m, which would be a positive m. You subtract, take the sign of the larger. Then I've got a minus n and a minus 6n. These signs are the same, so I add and take the sign. So the simplified version would be m minus 7n.